Who here would love to be able to control their genetics? What if you could make it so obesity never ran in your family again? Or if you could have the cancer that runs in your family never affect you? Hi, my name is Mary. Welcome to my nutrition education class. Today's topic is on nutriepigenetics, which more or less lets us control our genetic output. No, nutriepigenetics is not a magic cure-all, but it may help you have some control over your health. Are you ready? Let's begin. Nutriepigenetics is a new area of food science that studies how the food we eat affects the way that our genes are expressed. This means that chemicals in food can either turn on or off our genes, impacting the way our body reads them.
Mary, what is a gene?
That's a good question. Let's find out. A gene is a specific sequence of nucleotides or a code that expresses certain traits in individuals like you and me. We inherit our genes from our parents. It is what makes you, uniquely, you. Do you ever wonder why you have brown or blonde hair? Well, there are certain codes or genes that express specific hair colors. You inherit one allele, or variant, of a certain gene from your mother, and one variant of that gene from your father. Whichever allele is more dominant out of the two will determine your hair color. Genes are created through DNA replication, transcription, and translation. This makes DNA and copies it over and over again. DNA sequences have specific patterns that results in specific genes. These patterns are comprised of what are called nucleotides that fit together like a puzzle. For example, A and B fits together and C and D fits together. So the whole DNA sequence is a specific pattern of A, B and C, D over and over to create the genetic code. Once the sequence is created, there is a protein that is able to copy this sequence. The protein pastes the sequence over and over again, which is the beginning process of the genetic code.
So, Mary, how does all of this relate to food and nutrition?
Well, an amazing phenomenon is that what you eat and the lifestyle you lead can alter the genes of you and your future children. Doesn't mean the gene is gone, it's just expressed differently. Meaning, the DNA code we discussed prior may be copied differently. For this to happen, a chemical component, called a methyl group, needs to be donated from a food to the gene. This addition of a methyl group to the gene either turns the gene on or off, causing the body to read and express the gene differently.
That's really cool, Mary, but I am still a little confused about how all of this works.
Well, David, think of it this way. If you're reading a book and decide to skip a chapter, you still have the same book, but the way you understand the story is different.
Okay. That makes a little more sense. So the type of diet we eat and the lifestyle we lead can change the story.
Exactly. By having a healthy diet and lifestyle, you can change the story of your life, and the lives of your offspring, for the better. Foods that are good at donating methyl groups are foods that contain the nutrients choline and methionine. Foods that contain these nutrients are oats, chicken breast, sunflower seeds, and Brazil nuts. The nutrients folate and vitamin B12 also play a role in DNA methylation. You can find folate in foods such as fruits and vegetables and vitamin B12 in animal products or fortified cereals. These foods, if consumed in proper amounts, can have an impact on cancer risk, autoimmune disease, addiction, memory loss, and also different psychological and neurological disorders.
So you're saying, if I consistently include foods that participate in DNA methylation in my diet, I can avoid these diseases?
It definitely can help.
Wow, that's so cool. So I should start including those in my diet right now? Wow.
Actually, David, since the changes in epigenetics can have long-lasting effects, it's even more effective when these changes occur before a mother is pregnant.
So what happens if the mom doesn't eat those foods?
For example, say the mom isn't getting enough of these foods in her diet before or during her pregnancy. Her baby's genes may not have enough methylation to successfully decrease the risk of obesity. That can have a permanent impact on the child's life.
So, Mary, you were saying that the choices I make in my diet and lifestyle today can change the lives of my future children?
Precisely. If you are someone who has cancer or obesity running in your family, you can take initiative right now by changing your diet and lifestyle choices. You have the power right now to combat these diseases by reducing your risk of having it affect you and your future children. An example of a specific gene that is known to cause health problems is the MTHFR gene. A certain variant of this gene, when it is turned on, can heighten your risk of blood clots and stroke. This variant of MTHFR, when combined with a low folate diet, for example, can increase the risk of cardiovascular disease in your family. So, if you know that your family has this gene's variant, then you can go on to add more folate-rich foods to your diet such as avocados, mangoes, spinach, and lentils.
So if foods containing folate, choline, vitamin B12, and methionine are foods I should include in my diet to have positive effects on my genes, are there any foods I should avoid?
Well, David, studies have shown that having consistent high blood sugar can damage the ends of our DNA code. We want to protect the ends of our DNA codes, for those protect us from cancer and aging. Foods that can consistently raise your blood sugar is a diet rich in simple carbohydrates. These can be found in candy, sugar-sweetened beverages, pastries, white bread, etc. This doesn't mean you have to cut these foods out cold turkey, just make sure to eat them in moderation.
Okay, thank you Mary for teaching me about nutriepigenetics.
You are welcome, David. Nutriepigenetics is still a new and upcoming study in the world of science and nutrition, but the saying may be in fact true that you are what you eat.